third presentation of the afternoon, and no 2110 event is complete without plenty of PTP, so let's have some more PTP. You probably had some this morning if you're listening to Thomas, but we're going to have some more now. So, and who better than Imagine Communications' Leigh Whitcomb? He is our second SMPTE Fellow of the afternoon. He's an architect at Imagine. He participates in SMPTE, VSF, and the AIMS standards committees. And he provides incredible levels of active involvement in the standardizations that have led to 2110, 2022, and of course 2059. So lots of experience gleaned from real-world customer deployments and from his contribution to the extensive ongoing 2110 industry interop event. So please welcome Leigh to the stage.
So you're wanting to do a 2110 system, so having a PTP infrastructure is one of the critical things. So my talk today is going to talk about how to successfully commission a PTP system. There are lots of ways to do it wrong. There are ways to do it right. We're going to focus on sort of how to successfully do it. Okay, just a few sort of rumors and facts and fiction here. So some people believe that, actually, question first is, how many people have deployed a 2110 system or about to deploy a 2110 system? Okay, a few people, good. Okay, so a few facts and fictions to go over. So some people believe that PTP systems are sort of black magic or mystical. Now, they are more complex than our sort of traditional analog black systems, but they're really not all that mystical. Sometimes I hear people saying that PTP systems never work well, they always have issues. So out of curiosity, how many people have sort of heard this or experienced this? Not too many people? Okay, good. Oops. So it's true if they are designed, implemented, and commissioned poorly, they don't work well. However, if you sort of design, implement them, and commission them properly, then they work really well. So that's what we're going to sort of focus on today. So one of the key things is starting with a very sound design. There's many different architectures you can use. This is sort of just a straightforward, simple one. One thing when you're doing your PTP system is you want to try to keep it simple. If you come up with some rather complex and innovative way, you'll probably have a lot of problems. So you sort of want to keep it nice and simple. So in a typical design here, you'll have two grandmasters, say, connected to GPS. For your priority 1 field, you'll have them to be the same, say, one on the two devices. That way, they'll use the GPS antenna to fail over. You'll have sort of different P2 values. You'll be using boundary clock switches connected to your media nodes. And then your media nodes, which are the key source of the users of time, that's sort of the most important thing. On your boundary clocks, for all the ports which are connected to media nodes, you want to use them in a role master mode, so you can sort of block out having any rogue masters in the system. On all your media nodes, you're going to want to set them to slave only, so they won't try to become the master ever. You'll have some links between your two switches, so that way the whole network will converge to the single grandmaster. So I said, lots of different ways, but you want to make sure you start with a sound foundation. What are some of the parameters you should use? As William was mentioning, there's the AES and SMPTE got together to sort of reconcile some of the differences in their profiles. So they came up with the AES R16 defaults. And as we're working on a new version of 2059-2, that's now going to be the defaults in the new version there. So these values here, now these values have been tested at, lots of experts have worked together to come up with these values are a good compromise between different options. They're tested at all the different, the JTM tested event that William was talking about. We have very sort of dirty hands and interop workshops. So at all those workshops, we always use these values. So they're very well tested. And for the most part, you have to have a very weird application to have a good reason not to use these. So I very strongly recommend you should use these values. They're well tested. They work really well. So your announce interval is 0, which is 1 message per second, 3 for your timeout. Your sync interval and delay request interval are -3 or 8 messages a second. What are some other good practices? So I mentioned you want to use boundary clock at the sort of lowest level connecting to your media nodes. So I mentioned you want to have, so because you have an architected network, you know which devices should be grandmasters, which ones shouldn't be. So on the devices that may be grandmasters or connected through networks to grandmasters, you want to set those into master-slave mode. And the ones which are connected to media nodes, you want to set those to master only. So that way you'll prevent any rogue masters. It'll just make your life a lot easier. For your PTP domain, if you sort of pick the non-default, then if someone plugs a random device in and it won't work, they have to, it sort of forces them to think, oh, I've got to change some of the parameters. So suggest not using the defaults there. As you mentioned on the priority field, so the two grandmasters and the two switches, they should each be the same. If you do have any sort of non-PTP switches in there, you want to turn on QoS and make sure you have the DSCP turned on. And if possible, you want to stick to only a V2 network. This is what we use for 2059 and for 2110 networks, and sort of avoid having any PTP v1 devices or in your network. A very important step is to make sure you get sign-off from sort of your critical vendors, so your grandmasters, your switches, and your media nodes. You come up with this design, and you may find that there's some special little feature you're assuming will be there, and maybe that's not implemented in your switch, or maybe the vendor, maybe your media node doesn't support -7 or so on. So while you're at the paper stage, it's very easy to go to all your vendors and basically say, will this design work? Do you agree with these parameters? So at the paper stage, very important to have those three different levels sign off on your design, because once you've built it, it's much harder to recable it and buy new stuff. So in the commissioning, so now you've sort of designed it, built it, now you want to make sure, is it really working? And one thing about PTP is it may seem to work, and it kind of works, but it may not actually be working as you expected. Where some issues can come up with this is maybe in your design you've got some issues, maybe some of the features in the products aren't there, you may have configuration errors as you were configuring all the switches on the devices. And unfortunately, some of the grandmasters and media nodes and stuff have bugs in them. So, some examples of where you'll see this happening. Say in the delay request, the default in media switches is 5, which is one message every 32 seconds. So yes, you plug a device in, it'll only do a delay request message every 32 seconds. It will eventually lock up, but in terms of your expected design, if you wanted the network to lock up, say, in less than 10 seconds, at one message per 32 seconds, that's not going to happen. You may have things like your unicast address is misconfigured, so your device isn't sending the delay request, and so you're never going to measure the one-way delay. So there's just sort of some errors you can have. Another one is there may be bugs in devices. So this was a few months ago, I was debugging something at a customer, and in their network, they were seeing different devices becoming masters every couple times a day, and it was very weird. As we sort of troubleshooting this, they properly programmed the grandmaster for an announce interval of 0, or 1 message per second. But the grandmaster was actually sending most of the messages at around once per second, but sometimes they're once every 2 seconds, and sometimes they're once every 3 seconds. And with having a timeout of 3, if the grandmaster sends a message every 3 seconds, then everyone else is thinking the grandmaster's died, the BMCA is running, new masters are getting elected. Now in this case here, it actually uncovered a few different things, because if their media nodes had been set to slave only, they would have never tried to become master. And on their switch, if they'd programmed the master only, then none of the other devices would have tried to become master either. So this actually uncovered sort of 3 different issues in their network, a bug in the grandmaster, as well as some configuration errors. So there's sort of different examples of how your system may seem to work, but it's not actually working. So in our commissioning, it's very important to understand the behavior of your system. This may sound obvious, but you need to sort of think at a very detailed level, what is the expected behavior I want? How should my system be working? Which we'll sort of come back to later. You're going to need to verify that the grandmasters are working properly, the switches are all configured and working properly, and all your media nodes are properly. You're going to have various checklists to basically, because there's a lot of different things you want to check and verify, so you're going to have these checklists to go through. There's going to be lots of different tests you're going to do and measurements you're going to do to make sure everything's working properly. And then if you do have failed issues in your checklist, you're going to have to go back and troubleshoot them. So looking at these checklists, we're going to have different checklists for our grandmasters, our switches, and our media nodes, because they each have different parameters, they each behave differently. There's going to be a lot of items to check, so in my sort of slides, I'll show you just a few examples, but these lists are quite long. And for every item, you want to have a pass-fail criteria. You want to understand what value do I expect, what's an acceptable net value, what is unacceptable value. So for every item, you need to have this pass-fail criteria. So looking at a grandmaster's checklist, you're going to be focusing on the grandmaster parameters. You're going to be looking at the actual message rates that it's sending. You're going to be focusing on the packets leaving the grandmaster. And you're going to have two grandmasters at least, and so you also want to be looking at how are they locked to each other? Are they both locked to GPS, or do you have some sort of connections between them so that the two grandmasters stay in sync? So you're going to look at those kind of items. So this is just a small part of it, the checklist. I said it goes on for quite a while. So there'll be one section here that's looking at what are the PTP parameters. So the past ones are basically, did you type in the numbers correctly? Then we look at the actual message rates. So again, I'll say the announce interval. We're going to look at a Wireshark capture, which we'll talk about later. And so, say in the standard, we're looking for messages between 0.7 and 1.3 seconds between them with an average of 1 message per second. So that would be the pass criteria. We're going to have other parameters, like we're going to power cycle the system and make sure, does it power up correctly? Do all the parameters go back to how they were saved? So just items like that in our checklist. When we look at the switch has sort of two sides to it. One of them is acting sort of as a media node locking to the grandmaster above it, and so it's going to have a part of a checklist which is going to look like a media node, and then to the devices below it, it acts as a master, and so it's going to have a checklist which is very similar to a grandmaster's checklist. So it's going to be a combination of those two checklists. So we're looking at things like our boundary clock parameters. In the switches, there'll be a variety of global parameters, as well as there'll be per interface parameters we have to look at. And then when we look at the per interface, we have to think about, is this an interface going towards a grandmaster, or is this an interface going towards a media node? Because they'll have different things we'll need to look at. So again, looking at a sort of a part of the checklist. So the first part might be kind of similar. Then we get into sort of the next thing on a per interface basis. So in switches, they'll typically be counters. So we're looking at, say, we want to look at the sync and follow-up messages coming from the grandmaster. So we want to make sure that the number of follow-up messages matches the number of sync messages. That's good. If it's a one-step mode, we'll want to make sure that the follow-up messages are 0. If you've got the SMPTE TLV turned on, you want to look at sort of the management messages received and transmitted. So there'll be a variety of counters you're looking at to make sure, are they counting as you would expect? As we go on to the media nodes, so here again, you're going to verify the parameters. You're going to focus a lot of the testing around the locking, because the media node, the key thing is it's trying to lock to the master, the grandmaster. And then you're going to be basically looking at mostly at the packets coming into the media node. So where you focus your attention. Oops. So looking at sort of the checklist for one of those. So there's a section here on locking. So we'll look at, is the device locked? Is the time correct? So that would indicate that we're locking well. You want to make sure that the grandmaster ID matches the grandmaster of your system. So it indicates that you are locked to the correct device. Because the one thing with PTP here is you could be locked, but you could be locked to the wrong device, say if you have a rogue master in your system or so on. You want to be looking at things like what's the accuracy that you're locked to the master. So you have some sort of specification here, maybe like half a microsecond. You want to look at sort of the one-way delay compensation. You want to make sure that makes sense. Typically, say if you're missing your delay request messages, your one-way delay might be showing as 0. So that would indicate a problem. So here in the pass-fail, it has to be a non-zero value. You're going to be looking at the packets coming into the device. So again, looking at things like announce stuff. There are some packets you actually do want to look at leaving the device. So in the 2059-2 standard, one thing that sort of some people have had issues with is that for the management messages, you should not respond, but if you do respond, you can't do it as a multicast. Some devices we're doing as multicast, so you want to be looking at a Wireshark capture to make sure, are you sending any management ACK packets out? Alternative, you could say be looking at some of the statistics on the switches is another way of checking that. So we have these long checklists of different items we need to check. So how are we going to actually run these experiments and collect this data? So some of the data you can get is from the different devices. So through their various GUIs and APIs, there'll be control parameters that you can read back. There'll be various statuses you can read back. There'll be various counters that you can access. Wireshark is your friend. So with Wireshark captures, you can look at things, look into the packet fields, make sure that they're set correctly. You can look at the timing of the packets, because in Wireshark it captures when the packets were transmitted. You can then verify things like rates. Then you can also look for unexpected packets. So again, you shouldn't be seeing any management ACK packets. So you can look at Wireshark captures to look for these different sort of error conditions. There's some other sort of free tools here. So like PTP TrackHound, sort of allows you to analyze the protocol looking for grandmasters and so on. Many of the Essence tools also have capabilities to look at PTP. So as Williams mentioned here, actually a little plug-in for him here is there's the free EBU list tool, so it does a certain amount of PTP analysis, or they'll be adding more as time goes on. So there's a variety of free tools. There's also some sort of paid tools out there, but even from the free tools, you can do an awful lot. So looking at Wireshark, so Wireshark has a built-in 1588 analysis, or like packet decoding. So once you do the capture, you can basically just click on the packet. It'll sort of decode the protocol for you. So in this case here, we see the message, or the log message period is -3. So that matches what we expect as we programmed in our grandmaster, because we all follow the ASR16 values, and so -3 is what a sync interval should be. So in the checklist, there's one is the value implemented correctly? So here we can put a check mark, yes it is. We can go through all the other packets and look at some of their fields too. Another thing that's very important is to look at, say, actual message rates. So you may have the grandmaster says, I believe I'm sending 1 message per second, so we'll have the log message field to be 0. But is it actually sending that? So in our checklist, we'll have items to do that. So how can you easily do that? Well, if you do a PTP capture, you do a Wireshark PCAP capture. So to do that, you can do port mirroring. So you can basically take your device under test, take that interface, mirror it to another interface, and then connect the device to do a capture. Now, one thing to watch out for, especially like, say, boundary clock switches, is that the PTP packet processing in the switch is a little different than regular packets. So depending on the model of your switch, you may not actually be able to mirror outbound PTP packets. So just sort of check the manual carefully, check with your switch vendor, depending on which model and make you have. If that doesn't work, what you can also do is just use an unused port, configure it as boundary mode. You'll get a lot of the same data you need. It won't be exactly the same, but it's another way of looking at it. When you are doing this capture, you have to sort of ask yourself, what kind of device do you want to do the capture with? Depending on which tests you're looking at, you could just use a regular laptop or regular computer if you're just looking at things like protocol, or if you don't care as much about the actual timing number. So some of them you're just sort of looking at what's the message field content. So you can just use sort of a regular sort of capture device. Some of the tests you may want to be looking at very fine nano or microsecond accuracy. If you're doing tests like that, you'll want to have a special capture device. So there's various devices on the market which will allow you to do very accurate capturing. Okay, so we've done our capture, we've got our data. So in Wireshark, say if you want to look at message rates, very simple. You can click on the packet, click on, say, an announced packet. You say, filter on this kind of packet, set the time display to the seconds from the previous, and then just sort by time. So here's an example of a capture I did here. So at the top here, I clicked on a announced message. I said, filter on this. That's what's put it on the top line. I set the time field to the delta, and then I just did a sort on the time field. This was a capture which I did over, say, 24 hours. So most of the packets were just sort of at the top there were around 1 second per message, which was good. You'll then see about the next 25 messages or so were closer to 2 seconds, and then right at the bottom, there's a 3-second one. So using a technique like this, you can very easily see the message rates and sort of determine if there's issues. So how long you should do the commissioning? From what I've seen in the field, if you do have sort of these very intermittent devices, within a day or two, a device will behave bad if it's going to behave bad. So if you do like a 1 or 2 day capture, you'll basically have if it's going to have an issue, you'll see it. One nice thing about PTP, because the data rate is so low, at 8 messages per second, if you do a 24 or 48 hour capture, the capture file is only 100 or 200 megabytes, which is very manageable. So you can do these captures, which are many days long. Another important part of the testing is looking at sort of your redundancy, failover, and power-up testing. So it's very important in your system, you want to make sure that, okay, yes, if my one grandmaster fails, it'll fail over properly. But you actually want to do that to make sure, is it actually going to work? With that, you need to sort of understand the detailed behaviors. You need to understand how the ports are going to transition, and what's the timing of that. And it's important to understand that at a pretty detailed level. And a very important thing for all the media nodes is, if you do change from one grandmaster to another, they're going to be basically locked to each other. You're going to see a change of grandmaster ID, but the end devices should have no impact. So you should see no glitches on their outputs. You should see no changes in their phasing. So it's very important, if the PTP system is working properly and the media nodes are implemented properly, that when you do a failover, it should have no disruption. So it's a very critical thing in your testing. So just looking at sort of two different sort of failure cases, and they look slightly different, but you'll see these sequences a little bit different. So here, the GPS antenna fails. So then the clock class is going to drop. That's going to get propagated down. That's going to get propagated to the other side. The other grandmaster is going to say, oh, I'm locked to GPS. You're free running. I'm better than you, so I'm going to become the master. That's going to start driving it backwards in the system. Then the media node, which is really what we care about, is going to see the change of grandmaster ID on the B side. That's going to propagate over to the A side switch, and then it's going to see it on both sides. So here, when the GPS antenna failed, we saw only one grandmaster ID change. So subtle difference here. Now, instead of the GPS antenna fails, the grandmaster itself fails. So what happens? Grandmaster fails. The switch stops seeing announce messages. After the 3 seconds, it's basically going to say, grandmaster's dead. I'm now going to become the grandmaster. So the grandmaster ID is going to change to now the switch's grandmaster. So the media node now on side A sees a change of grandmaster ID to switch A. That's then going to propagate over to the B side. Then it's going to see it on the B side. Then it's going to go up to the other grandmaster. The other grandmaster is going to say, I'm locked to GPS. My priority one field is, well, actually, it's going to see my priority one field is better than yours. I'm going to become the grandmaster. So then this process is going to reverse. And then the media node is going to see now the grandmaster ID change to grandmaster B. And then it sort of works its way back. So here, a slightly different failure case. One, you're going to see one grandmaster ID change. Here, you're going to see two. Now, in the end, the media node behavior should be the same. But as you're trying to debug this or go through it, you want to make sure that you understand this, because if you're going through a Wireshark capture, you want to make sure these are the sequence of events you see. So here you have here's the expected behavior. Then you're going to test the actual behavior against that and make sure they match. And if they don't, you need to sort of figure out what's wrong. Monitoring is very critical. So you want to basically have a monitoring node that's going to talk to all the different devices in your network. They're going to look for critical parameters, things like grandmaster ID, lock status. It'll allow you to be able to sort of detect changes in the system. Right now, unfortunately, most vendors implement their monitoring differently. So one person might call it grandmaster ID, the one calls it GMID, one says it's locked, one says not locked. So SMPTE has created a working group, a drafting group here to basically look at PTP monitoring, and they're coming up with standardized parameters and standardized sort of encoding of values. This way, hopefully all the devices once this gets published and everyone updates their devices, all the devices will have consistent parameters, or at least for the critical ones, and consistent encoding, which will then make monitoring nodes much easier to detect things. Also, in the new version of 1588, the v2.1, which is coming out hopefully soonish, it also adds some capabilities based around monitoring. So when it comes to monitoring, sort of stay tuned from both IEEE and SMPTE for information on that. So for troubleshooting, one thing is if you start with going through the checklists, by doing that, it gives you lots of experience using the tools and sort of experience using sort of the different checklists. It helps you to sort of narrow down where the failures might be. And also, to do the checklist properly, you have to have a detailed understanding of your network, which is also very helpful in sort of troubleshooting. By using that monitoring system, you can help give you information about, oh, things on this switch are failing and things on this switch are good, which then help you debug. So looking at that monitoring data. And depending on the complexity of your problem, you may have to add extra packet captures or extra monitoring depending on how your troubleshooting is going. So don't be surprised if you have to hook up some extra Wireshark devices if it's a more complex issue. Sort of in conclusion, so PTP may appear to be working when it's not. So it's very important to sort of be careful with that. Just because it looks like it's working, it may not. Make sure to get sign-off from the grandmaster, switches, and media node vendors. Getting that upfront design right will help you a lot. You need to understand the expected behavior of your system at a very detailed level. You need to have these various commissioning checklists for both grandmasters, switches, and media nodes, going through all the different parameters you want to test. You need to very thoroughly check each part of the system. It may seem like a lot more upfront work, but having done this work, you'll uncover all the little issues, because if you try to just debug it after the fact more in an ad hoc way, it can take a long time to do that. Make sure you're doing your redundancy failover power-up tests, so you understand how it should work. Sort of go through that experiment of fail the grandmaster, fail the antenna, fail the link. Make sure that in all the different combinations, your system is behaving as you expect. Make sure to have that permanent monitoring system configured and installed and running. And lastly here, if you design, implement, and commission it properly, PTP systems work very well. Thank you, and any questions?
Okay, Leigh, thank you very much. I think I got two really good messages out of that. One was have a plan, and the other was get a monitoring system.
Yes.
I think those would be my takeaways, right? Do we have any PTP-related questions in the audience? Of course we do.
Uh-oh, it's Nicholas.
Thanks, Leigh, for that summary. I just wanted to ask you about your master changes when you switch between one master, when you deliberately fail the master rather than removing the antenna. Then the whole propagation you mentioned is sort of sequential, but I would assume it would be sort of quite immediate with all boundary clocks noticing that fail quite instantaneously.
Yeah,
Did you see something like a sequential sort of walkthrough of the BMCA, because that's something which shouldn't occur?
I mean, I'll say it occurs very quickly. I mean, when one switch goes over, then the next one it'll propagate in the next message, but it'll be sort of like the next message. So it's a very quick propagation, but it's just important to see that as you're looking through it, you'll see one of them you'll have an extra message, or it'll be a slightly different message. So it is a quick change, but there's a slight sequence to it.
That I beg to disagree, because I believe that's implementation specific. You wouldn't see that by every device.
Possibly, yeah.
Yeah. Okay, thanks.
Okay, thank you very much. Can we have some appreciation for Leigh?